Hi, George Diamond here, and once again we're continuing our my flipped classroom lessons. This is our next lesson. We're kind of in the middle of a unit on differential equations. So today we'll be looking at, in our textbook, what is section 6.3, separation of variables. Now my classes, my students, as we've gone along through integration, differentiation, occasionally in each section in our textbook we'll run into a differential equation or two. So my students have kind of seen them a little bit. But now what we're looking at today in this unit in our textbook, this is mainly just an introduction to differential equation. So we're really not going to look at that many applications. There's a lot of applications to differential equations in engineering. We're not going to get into anything like that. So basically, in this unit, if you've got a basic, if you can have a basic skills of integration, if you can integrate pretty well, some algebra skills, you're going to be able to work all the problems that we're going to be looking at here. Now today we'll be looking at a particular technique of solving differential equation. It's called separation of the variables. Now first, we remind everybody, let's take a look at, let's define what a differential equation is. A differential equation is simply an equation that involves x, y, and the derivatives of y. Or as my calculus teacher always said, it's an equation with a derivative in it. All right? So an equation that involves x and y and the derivative or derivatives of y. All right? Now also you talk, as we look at some of these problems, you need to know what the order of a differential equation is. Now the order is simply the highest degree or the highest derivative in the equation. Now, for the most part, most of the problems that we'll be looking at today are first order differential equations. That means they have a first derivative in them. So dy over dx, that's it. But keep in mind, there are second order differential equations would have a second derivative in it. So it's the highest derivative in your equation. That's what we mean by the order of the differential equation. Now, a little bit about separation of variables. Now, separation of variables is really pretty simple if you've got, but it really is, for some students, it's kind of the most difficult part of the integration process for some reason is basically just some algebra manipulation, right? Now, some things to note about separation of variables before we get into our first problem. Now, whenever we separate the variables, this involves a technique where you rewrite the equation so that each variable occurs only on one side of the equation. Right? So that each variable occurs only on one side of your equation. So you want your x's on one side and your y factors on the other. Now specifically, this is a good rule of thumb, and if it's not followed completely, that's okay, but this is a good rule of thumb. On the left side of your differential equation, you want your y factor or y factors. Right? So you want y on the left. So your y factors. Now on the right-hand side of your differential equation, you want your x factors, any constants. So if you got a constant, a numerical constant of some type, and negatives. Right? So you want those all on the right-hand side of your equal sign. So on the left-hand side, basically all we want is the y factors. And on the left-hand side, any x variables or x factors you've got. Any constants and any negatives. So if you've got a negative, we want it on the right-hand side of our equal sign. Now, I also put up a little example here real quick. This is just an example of a differential equation that has not been separated and one that has been. So look at my example here. Now, this differential equation is one that has not been separated yet. You got x squared plus 3y times dy dx equals 0. Now, this is a differential equation. This is a first order differential equation that is degree 1. Now you take this same equation and you separate the variables. Right? So you want the x's on the right, the y factors on the left, and we get this differential equation right here. We have y times dy equals negative 1/3 x squared dx. Now you want to notice here, okay, that on the left-hand side, all we have is the y factors. Okay, you have y times dy. Right? Now on the right-hand side of our equal sign here, okay, you've got the negative. Okay, we got the 1/3. Right? We got our constant factor on that side, and we've got the x squared factor. Right? So on the right-hand side, you got the negative on that side, the 1/3, your constant factor, and you've got the x factor and the dx all on one side. So everything with x in it, we want on the right, including any negatives and any constants. The only thing I want on the left-hand side is the y with the dy. That's it. So once again, this is the differential equation that has unseparated, right? With the variables unseparated, this is the same equation with the variables separated. Right? So typically when we solve a differential equation, that's the first step. You've got to be able to separate your variables. And which is basically just some algebra skills, some multiplication and divisions, typically. All right. So let's get started here. We'll look at, now we've got a bunch of examples lined up here, so we'll run through these pretty quickly, how to separate the variables on some of these. So let's take a look at a couple of examples. So our first examples. And let's see if I can get this erased. There we go. All right. Now, the first thing I want to show us, though, is this right here. A lot of students have not seen this type of expression in an equation yet. But we're going to run into this type of e expression, right? So as we look at some of these problems, you're going to see this type of expression, e to the x plus c. Now, this is not a differential equation, but I just want to show you. So when you run into this in some of these problems that we're working with that involve e, right? Involve e, how this comes to how we simplify this type of expression. So you got e to the x plus c. C would be our constant integration here. This is equivalent to e to the x times e to the c. Where you got addition in your exponent, right? And we can break that apart as multiplication. So base e to the x times base e to the c. Now e to the c is, once again, that's going to be a number or a constant. So what we have here is e to the x times c. Right, constant c, usually written as c e to the x. So this becomes that. All right. So I just want to kind of point that out. A lot of students, have not seen that type of relationship. But just keep in mind, we're going to break this apart because it's addition. Right. So e to the x times e to the c, and you're going to see this several times as we get into some natural log and e problems. We'll see this. Now, also before we take a look at our first example, you hear the air conditioning coming on there. Okay, let's take a look at a differential equation that's easily separable. All right, so this one is separable. Let's take a look at one that's not separable. So let's do one that is separable and one that is not separable. All right, so this is an example of a differential equation. We'll do dy over dx equals x times y. Okay, this is easy to separate. Right, so very quickly we can have this one separated. The y's on the left, the x factors on the right. We can separate this one very easily. Now this one, dy over dx equals x times y plus 1. This problem we couldn't do. Right, so we would not be able to separate those. Right, we could not separate that. Okay, this one is easy to separate. You got the x times y, just some simple division, multiplication. We would have this equation separated with the y factors on the left, everything with x on the right. But this one here, we would not be able to do this problem in this class. Right? So this wouldn't, you would not be able to separate those variables there. I just want to show you an example of one that, like I said, that we could not do. So we could not do this differential equation. So let's take a look at several examples here. Now what we're finding here is we're going to see if we can find the general solution of some differential equations. Right? So some examples. So let's see if we can find the general solution. All right. Now what that means is we're going to find the family of, the family of curves, if you will. Okay, that satisfies that differential equation. So the family of curves, okay, that satisfies that differential equation. This is all right here. There we go. So a family of curves that's going to satisfy this differential equation. In other words, when you find a general solution, you're going to have C in your answer. Now, in the next video, we're going to look at some particular solutions, right, in which we're going to solve for C. But here, we're going to have C in each of our answers. So we'll start with an easy one here. The first example, let's do y prime equals equals negative x over y. Right. Now, first of all, y prime, I want to rewrite this as dy over dx equals negative x over y. I just want to rewrite it. Y prime is still, it's another way to write the derivative. Now keep in mind, dy over dx is not a fraction, but Remember what we said earlier in this class? That sometimes we treat it like it's a division, like it's a fraction. Technically it's not. We can treat it like it's a fraction. So first thing we need to do here, we need to separate our variables. I need everything with y on the left, everything with x on the right. So I need to leave that x on that side, and I need to get rid of the y. Now in this case, first thing I want to do though, let's break up this dy dx. So the dy on one side and the dx on the other side. So we're going to multiply dx here. Let's multiply dx over here. So that gives me dy equals negative x over y times the dx on the right hand side of our equal sign. Now you can see where y is in the bottom of that fraction, right? So we need to get y out of the bottom of our fraction here. Right, now to get y out of the bottom of our fraction, we're going to multiply y on this side. We'll multiply y to the left hand side. So we have y dy equals negative x dx. Okay. Now that's our first step. Okay, we've got, as you look at this equation, y times dy equals negative x times dx. Now you want to leave the negative on the right hand side with the x. Remember, the only thing we want on the left hand side with the dy is the y factor only. All right, so when we so as we solve, we're going to integrate both sides of our equal sign here. Now to solve this for y, we're going to integrate this side and integrate the right hand side. So we're going to find the antiderivative of both sides. Now, if you like integration and you like finding the antiderivative, you're going to love differential equations because you're going to integrate twice. Okay, once on the left hand side and then once on the right hand side. Now we're going to integrate y with respect to dy. Right, so this will give us, we're going to add one to your exponent divided by the exponent plus 1. So y squared over 2, that's going to be equal to. Now on the right hand side, the antiderivative of negative x would be negative x squared over 2, okay, plus our constant integration. Now this is it. Now typically, you may have to solve for y, but let's see if we can kind of clean this up a little bit. You notice that both the x and the y factors are both divided by 2 here. So I'm going to multiply everything by 2. Right? And this will give us y squared equals negative x squared plus c. And let's do one more thing. Let's bring this x squared over to the left-hand side. That'll give us x squared plus y squared equals c. Now, most of you will recognize now this is a circle. So this is the equation of a circle with a radius of c. So the radius. So this is the equation of a circle. Let's see. Let's do one more thing. Let's see if we can solve this for y. So if you have to solve your, if you have to rewrite your equation in explicit form, we're going to take the square root of both sides. Okay, that gives us y equals plus or minus the square root of negative x squared plus c. So if you have to solve it completely for y, you've got to do plus or minus the square root. A lot of times you can just leave it as y squared equals negative x squared plus c. All right, so this is our first example. Okay, so we end up with what is basically a circle, right? The equation of a circle. So this is our first example. Let's try another one. Right, so erase this. And we're going to find the family of curves, again, that will satisfy this differential equation here. So let's take, see, that was our first example. Let's try this one right here. Let's do dy over dx, so number 2. Yeah, so dy over dx is equal to, this time we'll do the square root of x divided by 2y. Okay. Now, so to begin with, the hardest part for most students is separating the variables. Now you notice on the right hand side you've got x and y. So the square root of x divided by 2 times y. We have to get that y on the left hand side of our equal sign. Now I'm going to start off, I'm going to multiply dx to both sides. So we're going to have dy equals, now the square root of x is x to the 1/2 power over 2y dx. So I'm going to start off by breaking that dy dx up. Now, let's say it's not a fraction, but we're going to treat it like it's a fraction. Okay, now I need to get this y out of the bottom of that fraction. Now, I want to leave the 2, and I want to leave the x to the 1/2. So remember, we're going to leave that constant. The only thing we want to get rid of is the y, because I want the y on the left-hand side with the dy. So to get y out of the bottom of that fraction, we're going to multiply y to both sides. And then we multiply y to the left-hand side. So that gives us y times dy equals, and this will be 1/2 x to the 1/2 power dx on the right-hand side of our equal sign now. Okay. Now notice in just a couple of steps now we were able to separate our variables. We got the dy and the y factor on the left. On the right-hand side you've got your x factor. Okay, we've got the constant, so the 1/2, and then the dx on the right. So you want most of your stuff, most of your factors on the right. The only thing we want on the left-hand side here with the dy is your y factors. So we're ready to integrate. So let's take the antiderivative now of both sides. Now the antiderivative of y is y squared over 2 again. That'll be equal to, as you find the antiderivative of 1/2 x to the 1/2 power, your 1/2 x to the 3/2 divided by 3/2 plus your constant integration. So find your antiderivative. Remember, you want to add 1 to your exponent, divided by the exponent plus 1. Okay. Now, let's see if we can simplify this a little bit. Now, we have y squared over 2 equals, this becomes 1/2 times 2/3 x to the 3/2 plus c. That's a plus c, and I can get rid of this, I think. I'll leave the parentheses. This will be 1/2 times 2/3. And now the 2's will cancel out here. And we have what y squared over 2 equals, and this becomes 1/3 x to the 3/2 power plus c. Now remember now, I want to see if I can solve this for y. So I'm going to try to write my solution in explicit form. So not implicit, so we're going to see if we can solve this completely for y. Now to solve this for y, all we got to do is get rid of the 2 here. So the next step here, let's multiply this side by 2. Multiply everything by 2. And we end up here, I'll break this up here, y squared equals 2 times 1/3 gives us 2/3 x to the 3/2 power plus c. Now remember, technically we are multiplying 2 times the c. Now c is a constant, c can be any number. So 2 times any number is still any number. So I'm not going to write that as 2 times c, we're just going to leave it as c. But technically we are multiplying the c. Okay, now keep in mind, sometimes we can just leave our answer like this. Y squared equals 2/3 x to the 3/2 power plus c. But if you got to solve it completely for y, we got to take the square root now on both sides. We have y equals plus or minus the square root of 2/3 x to the 3/2 power plus c. So this would be our general solution. Remember, this is the solution that represents the family of curves for this differential equation. Okay, also keep in mind now, when you look at a differential equation, a derivative is slope. So when you look at dy over dx, you're looking at a slope expression, right? So let me write that down, because remember, this is actually the slope of that equation at any particular point. So you have a slope expression, or a slope expression, if you will, for this particular equation. All right. Now let's try another example. And let's see, let me move my, I'm going to have me a little meal later. I brought me a can of soup here, so let me move that out of the way. Okay, let's move on to problem number 3 here. It's problem number 3. All right. Now, so we've got several examples we're going to run through. And so this is just basically practice on how to separate the variables. So let's try this problem right here. So number 3. Okay, let's do x times y. Let's see, x times y plus y prime, okay, equals 100x. So 100x. Let's try this problem right here. Now, once again, the hardest part is going to be separating our variables. Well, let's start off, the y prime here is the same thing as dy over dx. I'm just going to erase that. And in its place, let's write dy over dx. I'm not even going to write it down as dy as y prime, right? So it'll be dy over dx. Now, to begin with, see, we've got that addition here. So I need the only thing I can do here to start off, let's move this xy to the right-hand side. Now, keep in mind, it may be possible that we can't separate the variables. Now, we'll see if we can. I believe this one we can. So let's get rid of this xy here. So we have dy over dx is equal to 100x minus xy. Now, so let's subtract xy on both sides. And I'll tell you what, let's do. Let's go and multiply dx to both sides. So we have dy equals 100x minus xy times dx. Now make sure you put that in parentheses, because you're multiplying it to this difference on the right-hand side. Now you got to be real careful with addition and subtraction. If you have addition and subtraction in your problem, it's possible that we may not be able to separate that type of a problem. In this case, I believe we can, because notice, inside our parentheses, you have 100x minus xy. Both of these have x in them, so we're going to factor the x off. And I believe that's how we're going to separate the variables on this problem. So it'll be x times, this will be 100 minus y dx. There we go. Now, we got this factored now in factored form, x times 100 minus y times dx. Now, the 100 minus y, I need to get rid of that 100 minus y. And you can't just get rid of the y. This is a binomial, so we got to get rid of the whole thing. So what we're going to do, we're going to divide this side by 100 minus y. Cancel out. We're going to divide this side here by 100 minus y. And we have 1 over 100 minus y dy equals x dx. Okay, we've got, let's see, it looks like we've got this, we got the variables separated, and it took a couple steps. And I said for a lot of students, that's going to be the hard part right there. I mean, it's the algebra, the manipulation, trying to get the x's on one side, on the right-hand side, and the y terms on the left. So let's see. So we're going to, now, once we've got our variables separated, let's go ahead and solve our, get our solution here. So let's integrate on the left and the right. Let's do the x over here first. This will be pretty easy. The antiderivative of x will be x squared over 2 plus our constant integration. Now, the left-hand side, now you got to watch out. This is a fraction. Now, I've warned my students, anytime you see a fraction, you're looking at a natural log, more than likely. So you got to check. Remember, with a natural log, so remember when you integrate, if you've got u prime over u, du, or dx rather, okay, this is going to be equal to the natural log absolute value u plus c. So do we have a derivative here? Note here, the derivative of 100 is 0, the derivative of negative y is negative 1. So I'll tell you what to do. I need the top of that fraction to be negative 1 in order to have a natural log integral here. So what I'm going to do is I'm going to go ahead and stick me a negative on it. I'm going to make it a negative 1, but if I do that, I'm going to put me a negative out in front of the integral also. Right, so you can also do the same thing by u substitution, but this was pretty simple. I think we can get u prime over u fairly quickly here, right? And that's it. Now, so as we integrate the left-hand side, gives us negative natural log absolute value of 100 minus y equals x squared over 2 plus c. All right. Now, we're going to have to solve this for y. Now, first of all, let's get the negative off the natural log. This becomes, let's see, this becomes, so we'll make this plus, and we'll make this negative over here. Now, you don't need to make the c a minus c, once again, and plus, minus c, c just a number, so you don't have to mess with the sign on the c, but we do have to change the signs on both sides of our equal sign here. Now, keep in mind, to get y out of a natural log, we're going to raise both sides to base e. All right, so we're going to do e, natural log absolute value of 100 minus y equals, now the left-hand side, this becomes e to the negative x over 2 plus c. Okay, now e natural log, we can drop the e natural log, and this becomes the absolute value of 100 minus y on the left equals, on this side would be, now the c is going to end up out front here, would be c e to the negative x over 2. Now remember what we looked at the very beginning of the video, right? So if you end up with e to the negative, e to some quantity plus c, you can break that apart, that c is going to end up here in front of the e. Okay. Now, we're ready to drop the absolute value. Now, notice what happens now to drop the absolute value. Give you the absolute value of x plus y, which is 100 minus y, should be equal to plus or minus c e to the negative x over 2. Now, also, remember, c is a constant here, so plus or minus c, we can drop the plus or minus at this point. This is just 100 minus y equals c e to the negative x over c. So anytime we got that c here, we can basically just drop the absolute value, I believe. Now, let's see if we can solve this for c, or for y. So sorry, to solve for y. So let's subtract 100 on both sides, gives me negative y equals negative 100 plus c e to the negative x over 2. So let's subtract 100 on both sides, change the signs, get the negative off the y. So we have y equals 100 minus c e to the negative x over 2. And that is our general solution. Okay, so that is our general solution in terms of c. So c is going to be our constant of integration there. And just remember now, to get y out of a natural log, you're going to take, you have to raise both sides to the base e. So this would be e natural log of absolute value of 100 minus y, then you can drop the e natural log. This is one of our properties of natural logs we looked at in a previous video. Okay, let's try another example. Right, so we erase this. Okay. And let's see, that was our third example. Let's try number 4. Let's try some little trig example here. So number 4. Okay, let's take y prime equals x cosine x squared. X cosine x squared. Let's try this problem here. Now, first of all, instead of y prime, I'm going to write this as dy over dx equals x cosine x squared. Now, so we're going to rewrite it here. Now, so as we get started, now first of all, let's multiply dx to both sides. So this gives us dy equals x cosine x squared dx. So let's multiply dx to both sides. All right, I guess the dy on the left. Now notice, on the right-hand side, we got x cosine x squared dx. There's no y factors left on that. There's no y factors at all in our differential equation here, except for the dy here. So there are no y factors to remove here on the right-hand side of our equal sign. So we're ready to integrate both sides of our differential equation now. Now, whenever you integrate dy, you're basically finding the antiderivative of one dy, which is just y. So the left-hand side, that gives us just y. So this is going to be, that begins the start of our general solution now. Now, on the right-hand side, we have to solve x cosine x squared now. Now, cosine x squared is a composite function. We're going to use u substitution to solve this. So let's let u equal x squared. That means du equals 2x dx. Divide by 2x gives us 1 over 2x du equals dx. All right, let's do some substitution. This is x cosine u times 1 over 2x dx. The x's will cancel out. That gives us y equals the integral. Okay, cosine u this should be du, I'm sorry, not dx. So du, du. All right. Okay, that wasn't so hard. We were, fairly quickly on the right-hand side, we were able to use a u substitution to rewrite this all in terms of u. Now the antiderivative of cosine is sine, so now we have y equals sine u plus our constant of integration. And there should be a 1/2 also. So we got a 1/2 here to bring that 1/2 out front. So it'll be 1/2 sine u plus our constant of integration. All right. Then last, let's write our answer back in terms of x. So we have y equals 1/2 sine x squared plus our constant of integration. And this will be our general solution now on this little trig problem. Okay, let's try another example. So we're running through several. And once again, we're kind of practicing separating the variables on some of these, right? Because like I said, for a lot of students, that's the hardest part. You'd think the integration would be the hardest part, the calculus part, but it's the algebra that a lot of students have trouble with. So let's see if we can try several more examples here. Okay, let's take, let's try one more here. Let's try next one, that's number 5. So our next example, we've got x squared. Okay, plus, we'll do 3y times dy dx. So 3y times dy over dx equals 0. Okay. Okay, let's try this problem right here now. Now, to start off, we need to first let's get the 3y dy dx by itself. Let's move this x squared over. Okay, and that gives us 3y times dy over dx equals negative x squared. Okay. And let's see, now we got 3 times y times dy over dx. Now, I'm going to go ahead and multiply dx to both sides. All right, so we'll go ahead and break that dy dx up. So we have 3y, there 3 times y times dy equals negative x squared dx. So we'll multiply dx to both sides. Now, notice we actually have the variables separated here. So what I want to do, I really want this 3 on the right-hand side. So we're going to divide this side by 3. Let's divide this side by 3. The 3's cancel. That gives me y dy equals, this becomes negative 1/3 x squared dx on the right. Because remember what I said at the beginning, right? The only thing we want here on the left-hand side with the dy are your y factors. The negative and the constant, any x factors we need on the right-hand side. So now we're ready to integrate this. Let's see what we get. Now the antiderivative of y is y squared over 2. That'll be equal to. Now getting the antiderivative of negative 3x squared, or negative 1/3 x squared rather, is 1/3 times x to the 3rd power over 3, plus our constant of integration. And then simplifying this becomes y squared over 2 equals negative 1/9 x cubed plus our constant of integration now. Okay, now let's see, I want to get rid of the 2 here that's being divided into the y squared, so let's multiply everything by 2. That gives us y squared equals negative 2/9 x cubed plus c. Now, for most cases, I think this would probably be sufficient. You got to solve for y squared. Now, if you got to solve your equation completely for y, though, you got to take the square root of both sides. Y is going to equal plus or minus the square root of negative 2 times x cubed plus c. So if you got to solve it completely for y, this would actually be our final solution now for this problem. Okay, let's try another one. Let's try one with e. All right, so we haven't really done an e example yet. So let's try this problem. Okay, let's see, this will be problem number 6. And this time we have y times y prime, okay, minus 2e to the x equals 0. All right, so let's see what this here looks like now. Now, first of all, the y prime, I'm going to rewrite that. So erase this will be dy over dx. All right, so we'll rewrite that. All right, so we just makes it a little bit more convenient to work with. You can break the dy over dx up. Now, to start off, let's get the y dy over dx by itself. And like I said, it's just some algebraic manipulation here to try to get the y's on one side and the x's on the other. So let's add 2e to the x to each side. So we have y dy over dx is equal to 2e to the x. So let's add 2e to the x on both sides. Let's multiply dx to both sides, gives us y dx equals 2e to the x dx. Okay, that one was actually pretty easy, right? So fairly quickly we were able to separate our variables here. And let's go ahead and integrate the left-hand side and the right-hand side. Now this gives us y squared over 2 equals. Now the antiderivative of e to the x, remember this is equivalent to 2 e to the x dx. Remember the antiderivative of e to the x is itself, so this is 2 e to the x plus c. So as you integrate this side right here, it's 2 e to the x plus your constant integration. Okay, now we're almost done. All we do is multiply both sides by 2. It gives me y squared equals 4e to the x plus our constant integration. And like I said, this may be all we need to do, just solve for y squared, but let's go ahead and solve completely for y. We'll put it in explicit form, so y equals plus or minus the square root of 4e to the x plus our constant integration. So, and we are done. Okay, let's try one with a natural log in it. All right, so that one wasn't so bad with the e. Okay, let's try a natural log example. So erase this. So number 7. Okay, here we go. Now this time let's try xy y prime. So y prime minus natural log x equals 0. Okay, let's try this problem. This one looks pretty good. So make sure I got it copied down correctly. All right, I believe we do. All right. Now first of all, let me get rid of that y prime. All right, this is x times y times dy over dx. So we're going to rewrite that in terms of dy dx. Same thing. Yeah, let's start off by moving the natural log x to the right-hand side. So we want our x's on one side, the y's on the left. And that gives us x times y times dy over dx is equal to positive natural log x. All right, and now this term right here, you have x times y times dy over dx. Now, probably the next thing that I would do is go ahead and break the dy dx up right now. So this will give us xy dy equals natural log x dx. Because remember now, whenever you do this, we're treating the dy dx like it's a fraction, and we're actually multiplying dx on this side, and you're multiplying dx on the right-hand side. So you're multiplying it to both sides. Okay. Now we're not done yet. So remember, on the left-hand side, we still have this x factor. And so we're going to have to get rid of that x factor. So that means we're going to now it's x times y times dy. So we're going to divide both sides by x here. So cancel. It gives me y dy equals natural log x over x dx. Okay. Now I believe we've got our variables separated. Okay, so we've got them separated. On the left-hand side, all we have is the y times dy. On the right-hand side, we have natural log x over x dx. So let's go ahead and integrate the left-hand side and the right-hand side. Now this gives us y squared over 2. When we find the antiderivative of y squared over 2, that'll be equal to. Now to integrate natural log x over x here, let's see, we're going to have to use u substitution. Let's let u equal natural log x, and that means du is equal to 1 over x dx. So remember the derivative of natural log x is 1 over x. So multiply x to both sides, multiply x here, so x du equals dx. So x times du equals dx, so our integral on the left-hand side becomes u over x times x du. And then the x's cancel out, and we just end up with the integral u du. And here we have y squared over 2 still. So equals the antiderivative of u du. Okay, now the right-hand side we've got all in terms of u. We're ready to find our antiderivative here. So we have y squared over 2 equals u squared over 2 plus our constant integration now. Okay, so let's see. I tell you what, let's do. Let's go ahead and multiply everything by 2 first. So multiply this side by 2. So multiply everything by 2. And x is equal to the natural, or u is equal to the natural log x. And this gives us y squared equals u squared plus our constant integration. Now, remember we said u was natural log x. So now we have y squared equals natural log quantity x squared plus c. So we wouldn't rewrite it back in terms of x. And like I said, we may be able to just leave our answer like this, but if we have to solve it completely for y, we got to take the square root, plus or minus the square root of natural log x squared plus our constant integrations plus c. So that would be our final answer here. Let's try another one. Erase this. Here we go. So that one wasn't so bad. Okay, let's see. Let's try this problem right here. Let's try dy over dt. This will be number 8. So dy over dt equals negative 2y. Let's try this problem here. Now this is actually a problem off an old AP Calculus exam that was actually a multiple choice question. So I'm going to have to throw it in. In our next video, we're going to look at several problems of some old AP Calculus questions. So now let's see if we can solve this now. Instead of x and y, we're doing t and y. So in terms of t and y. So to get started, let's multiply dt to both sides. So we have dy equals negative 2y times dt. Right? So multiply dt to both sides. Now to separate our variables, we still got to get rid of this y factor here. So we're going to divide this side by y. We're going to divide this side by y. So dy 1 over y dy equals negative 2 dt. Okay. Okay, now that wasn't so bad. We've got our variables separated okay. On the left-hand side, we have 1 over y dy. Then we're going to integrate the left-hand side and the right-hand side. Now, the left-hand side, the antiderivative of 1 over y is natural log absolute value y equals. So you see that little fraction there, and that's a natural log. So the natural log absolute value y equals. Now, the left-hand side is negative 2t plus our constant integration. So remember the antiderivative of negative 2 is negative 2t with respect to t. All right, now to solve this equation, now remember we're going to have to get the y out of this natural log. That means raising both sides to base e. So this becomes e natural log absolute value y equals e negative 2t plus c. So you see this step? So we're going to raise the left-hand side to base e and the right-hand side to base e. And this becomes absolute value y equals, now the c we're going to bring down front here will be c e to the negative 2t. And then the y we can draw. This becomes y equals c e to the negative 2t, and that becomes our solution now. So that wasn't too bad. Now let's try another. Now we have 2 more examples, right? We'll quickly take a look at those, and like I said, we look at that, some different types of problems. All right, let's try another one. All right, let's try. Let's try this to be number 9. Let's try this problem right here. We'll do y times y plus 1. So actually times y times x plus 1, not y, so x plus 1. Okay, plus y prime equals 0. Okay, now let's see how we go about solving this differential equation. Now once again, remember we're just getting the general solution. Get the general family of curves that satisfies this equation now, right? So to start off now, first thing I want to do is rewrite this y prime. Right, so dy over dx. Now my students, as you write the problem down, if it's got y prime, go ahead and rewrite it as dy over dx. This makes it a little bit easier to work with, I think. Okay, now let's see, this is addition, so let's move this term to the right-hand side. So we'll move this one over, and that gives us dy over dx is equal to negative y times x plus 1. Okay, let's move that term to the right-hand side. Let's break up the dy dx now. So we have dy equals negative y times the quantity x plus 1 times dx. All right. Now, see, that wasn't so bad so far, so good. Now, we still have a y factor on the right-hand side of our equal sign. Now, remember, I want to leave the negative and get rid of the y. The negative stays on the right-hand side, and plus we're going to leave the x plus 1 factor. Now, get rid of that y, divide this side by y, divide this side by y, that gives me 1 over y dy equals, now this negative I'm going to distribute inside my parentheses. It'll be negative x minus 1 quantity dx. I wouldn't set it up like that, that'll work just all right. You don't have to do that, you can't just integrate and bring the negative out in front of your integral. Okay, now we got everything separated now. So on the left-hand side, we got the 1 over y. So the y factor is gone off the right-hand side now. We just have the negative x minus 1 times dx on the right. So we're ready to integrate. Let's integrate the left-hand side and the right-hand side. Now 1 over y, that's natural log. Natural log absolute value y equals. So always remember the antiderivative of 1 over y is absolute value, is natural log absolute value y. Now integrating negative x minus 1. Let's do the negative x. This will be negative x squared over 2 minus, now the antiderivative of 1 is x, and plus our constant integration. Okay, so that's going to be the antiderivative on the right-hand side. So remember, you're going to add 1 to the exponent, 1 plus 1 on the bottom, so it gives us x squared over negative x squared over 2. Now, remember what we said. Now we got natural log absolute value x on the left-hand side of our equal sign. To get that y out of that natural log, we're going to do base e to both sides here. So we have e natural log absolute value y equals, this becomes e negative x squared over 2 minus x plus c. Now remember that c on the end is going to come down in front of the e here. So we end up with absolute value y equals c e to the negative x squared over 2, okay, minus x. And then the absolute value we can drop. It'd be y equals c e to the negative x squared over 2 minus x, and that is our general solution. Okay, now let's try this next problem. All right. Now just to be a little bit different here, let me erase this. This will be number 10. Okay, let's finish up here. Okay, we're going to make this one a multiple choice question. Okay, let's see if we can. So we'll make this a multiple choice question. This is pretty good. I'll see if I can write these solutions down. So just kind of bear with me here as I get this set up. Now our equation with dy over dx is equal to x squared over y, or x squared times y. Okay. Now our solutions are going to be. So A, B, C, D, and E. So we have 5 answer choices here. Now the first one would be 3 natural log x over 3. Okay, B is going to be e to the x cubed over 3 plus 7. Okay, C is going to be 2e to the x cubed over 3. Okay, the next one could be 3e to the 2x. And then the last answer choice is x cubed over 3 plus 1. Okay, so plus 1. Now these are our different answer choices. Now, this is our differential equation. Now this is actually a problem off an old AP Calculus exam that has been released. Now this is what I want my students to do. Pause the video. Let me see if you can solve that differential equation and which one of these could be a possible solution. So you're going to get a possible solution. All right, so which one of those could be a possible solution? So if you would take it, now we're going to go over the answer here in just a minute, so I want you to pause the video. If you saw this on if my students saw this on the AP Calculus exam, how would you do on this problem? So pause the video. ahead and work this one, and then we'll bring it back up and see how we do. All right, so hopefully you got it worked out. So let's take a look at our solution then. Now, start off, let's multiply dx to both sides here to separate our variables. So this is dy equals x squared y times dx. All right, so multiply dx to both sides there. Now we got to get rid of this y factor, so we're going to divide both sides by y, and divide this side by y. So we have 1 over y dy equals x squared dx. Okay, now that separates the variables, so really not that difficult to separate. All right, so you know, if you were to see a problem like this on the AP Calculus exam, this is doable. You know, if you're somewhat familiar with how to the process of integration and separating the variables to solve a differential equation. Now, I'm going to integrate the left-hand side and the right-hand side. That gives us natural log absolute value y equals, this becomes x cubed over 3 plus c. Now, once again, to get the y out of your natural log, we're going to do e natural log absolute value y equals e to the x cubed over 3 plus c. And this becomes y equals, we'll bring the c down front, e to the x cubed over 3. Now let's see if we can match our general solution up with one of these particular solutions. So this is CE, what could C be? So CE to the x cubed over 3, and you can see the correct answer here would be C. So if you were able to work that correct, good job. All right, so you're getting some skills now. All right, so we've done 10 examples, some natural logs, some E integrals, some E differential equations, some trig, so a little bit of everything. Keep in mind, you know, as we go through this unit with differential equations, this is just an introduction. We're not going to be experts. To be an expert, when you go to college, you can take a differential equations class. They have classes of them in college. But you know, but at least here we'll be able to solve those equations that are easily separable. All right. Hopefully you found these 10 examples helpful. So now, time to do our homework.